Hey everyone, so today for you I have Leetcode question 86, and in this question you're given a linked list and a value, and you're supposed to partition it such that all nodes less than x come before nodes greater than or equal to x. So basically, if you are given like x equals 5, so I'll say x equals 5, you know everything to the left of 5 is less than or equal than 5, less than or equal? Okay, so everything to the left of a 5 or to the right of a 5, or everything to the left of the 5 is less than or equal to 5, and everything to the right of the 5 is greater than or equal to 5. So when I look at this problem, first thing I think, I haven't solved this yet, so the first thing I think is we have like a head. Oops. Let me kind of pick up my toolbar, handy dandy toolbar. Okay. So we have our head. It's kind of a big head. So we have our head. And if okay, so this is just like a regular partition, I'm thinking. So we have a head. So we compare this value to the value we're looking for. If it's less than it, then we can keep it. If it's bigger than it, then we want to take our next value. So we have our head. We compare this value to our 5. We say it's less than 5, so we say head equals head dot next. So then we look at the 8, and we also so we need to have a head variable and like a little mover variable, I guess. So make this head a little bit smaller and mover, or last node. So we'll say we'll have a head and a last node variable. So what we're going to want to do is we're gonna look at first we're gonna look at this 4, and if our first node is bigger than what we're looking for, we kind of have a little bit of a problem. So we'll save that for later. We'll assume our first node is less than what we're looking for. So we have a 4. So we can move our head over 1. So 4. And we'll just keep track of this last node. So then we'll say we have an 8. And our 8 is bigger than what we're looking for. So we don't want to attach the 8 to our last node. So we'll say we'll create a variable called last or first biggest or something, or the first node that's bigger than everything else. So we'll say like first biggest, and then we'll keep this here. So then we'll move our head over again. Oops. So we'll move our head over here, and then we'll say, okay, our last node dot next. We'll compare this value with what we're looking for. So it's a 5. So we'll say our last node dot next now points to the head because it's smaller. So this now it'll point to here. Got to do the fancy arrow, major key. So we'll have this, and then we can say our head equals our head.next. So we can move our head over. We'll compare this value. It's less than or equal, so we're good. So we move our head over again. Oops, I made a mistake. So we should have been moving our last node variable over 2 every time something's like a winner. So every time like this 8, we wouldn't have moved it. But when we attach the 2, we could put our last node over to our 2. And then we get to this 9. And our 9 is also worse, so we don't want to add our 9. So what we can do is we can say our first figure dot next. Oops. Our first figure dot next can point to the 9. So this can point to the 9. And then we'll have created another variable called like bigger mover, or current bigger. And originally we had our current bigger here, but then we'll move our current bigger over here. And then when we see that we're done, so we also want to set our last node should have become the 5 because we added the 5. So then we want to set our last node dot next equal to our head dot next. So I'll just create like a little null. Oops. So then our last node will point to head dot next. So null. And now that our last node points to null, we could have had like a kept checking last node equals to null, and we only put our last. So our last node points to null, and then our head equals our head dot next, and this was also pointing to null. So now our head is null. So now that our head is null, we can just say our last node dot next equals our first bigger. So what we were really doing there is we were kind of creating two last node dot next. So this is pointing to our first bigger. So I know this is a little bit messy, but if you look at it, the relative order that you have it in, you got the 4 first. So the 4 is pointing to the 2. The 2 is pointing to the 5. The 5 is pointing to the 8. And the 8 is pointing to the 9. So this is how you do it. It's partitioned. Now both sides of these are not sorted, but everything to the left of our value is less than it. Everything to the right of our value is greater. So I'm trying to think. So we didn't have any nodes less than our last node after it, which could be an edge case you kind of need to think about. Oops. So let's say let's kind of go back a little bit. Okay, so I'll create one more variable. I'll put it over here, and we'll make this like a 2. So our last node was 5. We went to the 9. We saw the 9 was bigger, so we made first bigger dot next equal the current bigger, or current bigger dot next equals to this value. Then we set current bigger equal to this value. And then we're going to set head equal to head dot next. So we're going to set head equals to head dot next. So head should now equal 4. We'll compare 4 to 5. 4 is smaller. So now we'll say our last node dot next will equal this 2. So our last node now next points to this 2. And then we'll say our last node equals our last node dot next. So this didn't work. So now this is our last node. Now you can see our 2 comes after our 5. Our second 2 comes after our 5, but we really should have switched it. So what we could have done, so this is why you always want to look at the kind of edge cases, or kind of exhaust all possibilities. So, so when we got to our 5, so we shouldn't have put our 5. We shouldn't have put our 5 into our last node. Perhaps we should have called this like an all 5s or something. So we could have like created like a node called like all targets or something. And we keep our last node at the 2. And then, okay, so I'm going to go back a little bit now that I've kind of figured this out. So we'll have our 5. Okay. So our 5 is going to be pointing to our 9. And you know what, I'll just start from the beginning actually. Now that I think I've got it. Okay. Make this brush a little bit bigger. A little bit bigger. There we go. Sorry, I just make it all in one video, so you're gonna have to wait. Okay. Okay. So we've got everything now. So we're gonna have our first bigger. Yeah, we're not gonna assign it to anything yet. Our last node, we'll just keep it down here all as well. Our all targets, we'll put it here as well. And then our, oops, this can be a problem. First bigger and then current bigger. Get it. And then we need our head. So as you can see, we've got a lot of variables going around here. So then we'll have our head. we have our first bigger and our current bigger, our head and our last node. So this time for head, I will just keep it pointing to the first one the whole time. I'll make like a mover. An all targets head. And then perhaps like an all targets mover. Okay. So, and then next case I'll show you if we have an 8 in the beginning. We'll switch these two values, see if it's any different. So we're going to put our head equal to our first value. Since it's less than it, we know we can put our first value here. And then we're going to put our last node equal, so we'll put our last node there too, because we'll put our last node wherever our head is. And then, okay, so I think that's where we're good. So then we'll say, and then we'll create, okay, then we'll just create like a mover variable. And we'll have our mover variable here. And we'll say our mover equals our mover.next. So now we'll look at 8. We'll say our 8 is bigger than what we're looking for. So then we'll set our first bigger equal, we'll move our first bigger here, and then our current bigger here. We'll move that too, because we have to keep track of where it starts and where we are in case we find any more of them to put more on there. So put our current bigger there. And then I think we're done. So we'll move. So we'll say, okay, mover equals mover.next. Oops. So then we'll look at the 2. 2 is less than it. So we can say our last node.next is equal to the 2. So we'll make this point to the 2. And then our last node will equal last node.next, because now we want our last node to be where the 2 was. So we'll move this here. And then I think we're done. So we'll say, okay, mover equals mover.next. So we'll put our mover here. Then we'll compare this value with what we're looking for. This value is the same. So we'll put our all targets head there. So we'll put our all targets head. And then we'll put our all targets mover there, just in case we find any more all targets, even though we kind of already know there aren't, just by looking at it, but we don't know that for sure. And then, so then we'll say our mover equals our mover.next. Get it? So we'll put our mover here, and then we'll say, okay, 9 is bigger, so we'll say our current bigger.next will point to, we'll have this current bigger.next point to this 9. Okay. And then we'll say our current bigger equals our current bigger.next. And then we'll have our mover move a little bit. So we'll move our mover over. We'll say, okay, our mover is less than it, so our last node.next can point to here. So we'll say, okay. And that's the reason I had to kind of put a variable at this 5 so we can find it later. So we'll say, okay, this is pointing here. And then we'll say, okay, our mover equals our mover.next. So our mover is Oh, and then we'll move our last node, actually. We need to do that too. And we lost some of our arrow, but such is life. Okay, and then we'll say our mover equals mover.next. So we'll just say mover equals null now. Oh, I'll move it actually. This is null. So now that it's null, we can say our last node.next is equal to our first like found node. So our 2 can now point, our 2 is pointing to null. But now instead we can have it point to our all targets head. So our 2 is pointing to our 5 now. And then we can say our all targets mover dot next will point to our first bigger. So this will point to our first bigger. And then our first bigger, or then our last bigger dot next will equal our current bigger dot next is null. Just so we don't have a continuous loop. We need to end it somewhere. So basically what we were doing is we kind of created 3 separate linked lists, one with values smaller than what we're looking for, one with values bigger, and one with values exactly, and then we just kind of aggregated them at the end. So if you can look, our linked list goes 4, 2, 2, where is this 2? I think this is going to the 5. So, yeah, 4, 2, 2, 5. 5, I think I had the 5 should be going. Yeah, our all targets mover.next should point to current bigger. So this should be going to current bigger. Oh, whoops, no. Shit. Yeah, sorry. This was pointing to our first bigger. So we want it to point to our first bigger, and then our first bigger is pointing to our current bigger, so it's kind of a good list we've got there. So now I'm going to go way, way back, hopefully, and I'm going to move the 4 and the 8 to see if we can kind of do the same thing. And I'm drawing in white pen. So here, what we would do, yeah, it would kind of work the same thing. So we'd start here, we'd keep going through them, except this time we would put our head wherever our first smallest value is, and then do kind of the same thing. So now I'm going to code this, hopefully. Let's zoom out a little bit. Okay. Just so I can remember all the variables I have. So as you can see, I haven't coded this yet. Yeah, so first thing I'm going to do is check if the head is null. So if head equals null, return null. And then I'm going to create all of those variables you've seen. So list node head equals first bigger equals current bigger equals target first target equals current target. So we've got a head equals mover. So we're just going to set a lot of this stuff. We already have a head. We don't want to set our head to null. So first bigger, current bigger, first target, current target, and then our mover, and then our equals mover. So our head is going to be our first small one. Okay, so we'll just start with this. Equals null. Okay. So we set all those variables to null. So now we're going to say mover equals head, because we want our mover to kind of be there. So we already checked if mover or head is null. So we'll say while mover is not null, if mover.value is less than target, so if our mover.value is less than our target, then we want it to be our head. So then we'll say head, we'll create a return value instead of a head, just so we have our own variable. So retval. So if it's less than it, we want that to be our head, but we don't know if we've already used our head yet. So we'll say if head equals null, or if return value is null. If return value is null, that means we don't have a node that we're returning yet. So we'll say retval equals mover. And if we do already have a value, so say we're at this 2, we already have a value. Retval equals mover. And then I'll just create a first lower and current lower. So I'll say first lower. So now I don't really need a retval. So if our first lower is null, then our first lower equals our mover, and then our current lower equals mover. Else if we have a current lower and we're lower, then we'll say current lower dot next equals mover. Oops. Current lower dot next is equal to mover, and then we'll say our current lower equals current lower dot next, and we'll kind of do kind of a similar thing with if mover equals value. Oops, mover.val. So if it equals target, we'll say if our first target is null, first target equals mover, current target equals mover, else current target dot next equals mover, current target equals current target dot next. And then I'm going to kind of do the same thing. I guess this should be else if. And this could be an else. So this is when mover is bigger than target. So if first bigger equals null, first bigger equals mover, current bigger equals mover, else current bigger dot next equals mover, current bigger dot next. Okay, so this should kind of create our three lists. So when mover is finally null, we'll like kind of append our list, but we have to be careful for in case like we don't want to get any null pointer exceptions, so we have to be careful about that. So so what we'll do is first we'll check if current, or if first, what do we call it? First lower is null. So if our first lower is not null, that means we've had a lower. And so what we can do is we can check if we have a current. So if we have a first lower and so if we have a first lower, and if first current, or if current, what are they called? First target. If first target is not equal to null, then these two both aren't null. So if first target, then we can say current lower dot next equals first target. If this is null, so if this is not, so else, if, I'll just write it out explicitly to make it a little less confusing, first target equals null. So if our first target is null, then we'll check if we have a bigger one. So if first bigger is not null, then we'll then what we'll do is we will first bigger. So we'll say our current lower dot next equals first bigger. Then we'll so this is like attaching. So we'll attach lowest dot lowest list to biggest list. And then we want to destroy the end of the biggest list just to make sure it's not still pointing to anything. So we'll say biggest list. Well, actually, we can do that. We can do that right here, actually. Well, we can do it after this while loop. We can just check if it's not null. Well, we'll see. We'll just put it here. We might refactor. So current bigger dot next. Okay. So we've so if our first lower well, I'm going to get rid of this actually. It's kind of confusing me. And I'm just going to put this right here. Give me 1 second. Okay, sorry about that. So if our first lower is not null, also first target. Okay, I'm just going to start this next loop. So else, this is if our first target this is if there's nothing lower. So then we'll say if so okay. So I was thinking this is if our first lower is null. Just attach middle and right. Okay. So if first target is null, so that means we don't have a middle. We can just return first bigger. And if we do have a middle, or if we don't have a right, so if first bigger is null, we'll just return our middle. So current return first target. So if one or the other is null, something will get returned. If neither are null, then we'll say current target dot next equals first bigger, current bigger dot next is null, return current target. Okay. So if our first lower is not null, so if our first target is not null, then we'll attach. And then so if our first target is not null, then we'll attach. And then we'll check if current bigger is not null, then we'll say our first bigger. Then we'll say our current target next equals first bigger. So if it is null, then we'll return first lower. And we'll say current target dot next is null. So we have covered if our first lower is not null, then if our first target is not null, then we have covered if our first bigger is not null and or if it is null. Oops. First target. Oh yeah, first lower. So if our first lower is not null, we're always going to be returning first lower. So I'm going to create a little sheet just to make sure. So, well, actually I'm not. So we have if our first lower is not null. We have if our first target is not null. So there should be 8 possibilities. Yeah, a little bit hard to think about. So if our first lower is not null, if our first target isn't null, then we attach the 2. If our first target is null, so else, if our first bigger, so the middle is null, then it checks if the bigger is not null. If the bigger is not null, then you attach, and then else middle and bigger are null. So you can just return first lower, and you don't even have to worry about all that kind of stuff. So I'll just leave that there. So I think we might have exhausted all of the situations if our first lower is not null. We check if our first lower is not null, our first target's not null, and our first bigger is not null. Our first lower is not null, our first target's not null, and our first bigger is null. Then we have if our first smaller is not null, if our first bigger is null, so then it checks if first bigger. So we've got like not null, null, not null, and then not null, null, null. Okay, so I think that's right. So this is if our first target is null. So if oops, this is if our first lower is not null. So if our first target is null, then we'll return our first bigger. If our first bigger is null, we'll return our first target. If neither are null, and if both are null, well, I don't think all 3 can be null. Yeah, the only way all 3 would be null is if everything was null. So if neither are null, current target.next equals first bigger, and current bigger.next equals null, and then return. So I think I'm going to run this, see what happens. Probably some bugs somewhere. It's kind of a long one. And I probably have some code I could shorten down a little bit. Compiler error, great. Let's check over. I think I have semicolons everywhere else. I usually do it. Nope. I usually am the biggest culprit at like the front at first. Let's see how long I've been working on this for. 43 minutes. Come on, line 11 cannot find first bigger. And I initialize this all wrong. I'm not even sure if I'm allowed to do this. It's been a while, okay. 15, cannot find mover. And I forgot to say mover equals mover dot next. I would have gotten an infinite loop there. Cannot find target, 17. And of course it's called x. Target equals x. That's the lazy way. First blower might not have been initialized. Okay, so yeah, I do have to say equals null. And target equals x. So say equals null. Okay, and we'll copy and paste this over a bunch of times. I'll copy over the space too. There we go. Okay, hopefully this should work now. And it might not work. Totally the possibility. One, 1, 2, 2, 4, 3, 5. And memory limit exceeded. Okay, that's fun. So that means we probably have an infinite loop. Oh, hot dog. So I have this while loop. What other loops do I have? So that'll return, that'll return, that'll return. Hot dog. So while mover is not equal to null, is mover equal to head? We already checked if head's null. So maybe this not getting hit. Well, hot dog. Maybe I need to put this up here. No, I do not want to change your color. I swear I already clicked that, but memory limit exceeded. what you always do. You always just run it again. See what happens. Maybe we'll give you a little more help. Did I say mover equals mover.next? Okay. Int value equals mover.value. Actually, I don't want to do that because everything's based on where my mover is. Maybe my if-else structure got messed up, so we've got this, this, this. Let's see if it makes it here. So I would have failed this if it was an interview. Okay, no smiley faces since we haven't gotten it yet. So if we don't make it there, then we're stuck in some sort of infinite loop, which is bad, very, very bad. So it did make it there. Huh. Let's see if it makes it here. We didn't return anything. And we'll create a bunch of returns, see if it's returning anything. Return 6. Return 5. Return 4. Return 3. Return 2. I guess we don't need this. Just because this if statement got executed, and then it's just gonna do that afterwards, so we'll get rid of that. Wait, what? Oh, yeah. Okay. I'm not sure why we're running out of memory. It didn't say anything. I did preserve the relative orders. Come on, standard out. Line 90, unreachable state. So we're not getting there. Okay, that's good. We don't want to get there. That would mean neither our if nor our else got executed, which that would suck. Just got a lot of views. I'd be rolling in the dough. So it returned 2. Huh. So it's returning first lower. So maybe I messed up the logic here. And there's a sort of infinite loop. There's something going on. The first lower is not null. Else we'll say maybe this is the current lower. Dot next is null. But I believe in it's giving us a 3, so we should have all 3, so nothing should be null. Okay. So I set current lower dot next equals first target. Current target first bigger. And then I need to set current bigger dot next. No. So first bigger, first target's not known. Yep. I think I talked about that a little earlier, that might need to be null. But I was like, no, I'll do it later. I wouldn't be surprised if it still didn't work. 1, 2, 2, 3, 4, 5. What? How is 1, 2, 2, 4, 3, 5 if it's looking for? Why is the 4 to the left of the 3? Partition it such that all nodes less than x come before nodes greater than or equal to x. Oh, I made it so all nodes bigger. Oh. So I should really only have 2 lists, because the bigger ones don't really need to be after x. They just need to be in the same relative order. So I made this a lot more difficult than it needs to be. It's actually a lot simpler. So what we'll do is we can just get rid of our bigger stuff. Well, we'll keep the else. So we'll just get rid of our current target. So we'll say else, and we'll get rid of everything that says current. Else. Okay. So, well, sheesh. It's kind of inconvenient to get rid of anything because I have all these damn if statements. So if mover is less than target, okay. If mover, so we'll get rid of the bigger stuff. We'll get rid of the movers bigger than target stuff. So we'll get rid of everything first bigger. First bigger is not null. Else if first bigger is null, so we don't need that. Oh, and we'll get rid of if first bigger is null. Middle, so we don't need middle one, right? Okay. So I got rid of everything here. I'll get rid of current bigger. And first bigger. Okay. So this all should be here. Then we get to the meter here. So if first lower is not null, if first target's not null, then current lower dot next equals first target, and first target dot next, our current target dot next equals null. Else current lower dot next is null. I don't think we need this if there were no targets. Yeah, we don't need this. And then else if first lower is null. If first target is null, that shouldn't happen. They won't both be null. I already checked if they're both null. Well, they can't both be null. Else first lower equals null. Current target dot next. We don't need this, and we'll just return current target. I hope it keeps your code so I can that was a good partition. If I ever have to quick sort something, that would be how you would like quick sort linked list. That's how you partition it. And we get 1, 2, 2, 3. Huh. So I'm not getting anything bigger. I must have messed this up. Movers. Oops. If it's less than target. No. I don't want to check else if it's equal to target. I just want to return it. This is why you always ask questions beforehand. Important tip. Very, very important tip. One, 2, 2, 4, 3, 5. Okay. This is where it gets legit. Submit it. And I never submitted my old ones, so I guess they're lost. That's okay. Good practice. Come on, judge. Wrong answer, 1, 1. Output, just 1. Huh. Why would I just output just the 1? Huh. So if I have a 1 and a 1, and I'm looking for the 0, so while mover is not null, if mover, so if 1 is less than target, no, else. If first target equals no, first target equals mover, current target equals mover. Okay, now mover is the second one, else. Current target dot next equals mover. Current target equals current target dot next. Should have both of them. If first lower is not null, else. Current target. We don't want to return current target, we want to return first target. I was just returning the second node in my list when I wanted to return the whole list, and I wasn't returning the head. I was returning the last element in it, actually. There we go, accepted. Let's see how we did. 100%. Oh, 2%. Dang, we suck. Well, it's probably all the print statements. Those take forever. Well, I guess there weren't a lot of print statements. Print. We'll get rid of these print statements, see if that speeds us up. I also have a lot of extra variables, so ret val is not null, don't need that. First node, first target, current target, first lower, current lower, mover. Okay. Well, I could be a little bit of a badass and put current lower, just make it a little bit shorter. So that'll save me. It won't make it any quicker, but makes it not even easier to read, actually. Just combining those two into one. So first lower, not null. First target's not null. So, well, first lower. Huh. Let's see now. Maybe I sped it up a little bit. Is there any print still? Okay, no print lines. Come on, 99th percentile. There we go, 100%. Hot dog. There we go. Okay. That's how you do it. That's how you solve a problem in real life in an hour and 5 minutes. You won't have that much time for an interview, so you gotta be quicker, ask more questions at the beginning, and don't be stupid like me, and you'll save some time. So I hope you guys enjoyed. I enjoyed doing this. I'll make sure to put the code on my GitHub. I guess if you want, you could look at the code on here. You can just go to a certain spot in the video. But if you want to see how to do it for the full list, I guess that would be how you do it. But I will link it in the description, so I hope you enjoy.